Hello everyone and welcome to another stream where myself and Roberto here
Hello.
are always trying to find new excuses to learn Rust. And today we're going to continue with our latest streams where we were trying to build a BitTorrent client following one of the tutorials that you can find on CodeCrafters. We will have a link in a second where I can find it. But meanwhile, I think I'm just gonna pass the ball to Roberto so we can jump straight into the CodeCrafter UI and then looking at where we left it at last time and continue from there. Today we might be doing some refactoring or just continuing. I think we'll be figuring out on the fly as we go. And feel free to suggest if you prefer that we improve our code. That right now is not great. We're just trying to make the exercise pass. Or if you prefer to just progress on the exercise and maybe we'll do a full refactoring later. Anything you want to
Is
add?
working on my laptop.
Yeah, works on your machine.
Yeah.
Okay, cool. Let me put your screen on. Hopefully this works. Seems to work. By the way, Roberto has a new background, so gives us a thumbs up if you like it.
Yeah, so I can tell ChatGPT that it was a good AI. So, I'm on. Yes, I am. Cool. So last time we were downloading a single piece from our metadata, from our torrent file. In the metadata, there is the list of all the pieces of the file that you want to download and to check if the piece that you download is good or not. So there is a checksum basically of what you are downloading. We left last time where we were sending out bits and bytes, doing the handshake and downloading the file. Offline, we finally made it work with the bad solution that Luciano was talking about. It's not a lot of changes. We were mostly right. We had a problem, like we said in the last stream, with the last block of the piece because you have to download this piece in blocks of 16K. And these, but obviously not all pieces are a multiple of 16K. So the last block of this piece can be less than 16K. So, and the protocol is peaky, and also Rust is peaky with the memory allocation of arrays, peaky by peaky. So when we found a solution that is not perfect but is working. So you can see here that the tests are passing it now. I still have to submit this to CodeCrafter through their command line client because we were not sure if we were going to refactor today this solution with a proper one or go on with another dirty one for the next bit that is downloading the wood file. Anyway, tell us in the chat meanwhile I explain what the code looks like now, what you want to do. So jumping in our code, okay. We were implementing a command. We have all the enumeration for our commands. The command that we were implementing last time was download this. We have our output file, the torrent file, and the index of the piece from zero based that we want to download. The code is exactly like last time. So we are parsing the torrent file. We are looking if this is the, where is it? If it is the last piece that is slightly different in size than the other ones, or if it is the one in the middle that is of the right size. Then,
Roberto, sorry, can you maybe
yeah,
make a +1 on the
plus one,
sides?
like this.
That's much better, thank you.
Okay. Then we allocate a vector of U8 that is our buffer. We tried with arrays. We tried last time, if you remember, we had some struggle here, and in the end, we settled with a vector of U8, even if it's not in the stack, but is in the heap. Yeah, performance-wise, we are fine. Cool. Then we do all our handshake, sending out directly arrays of bytes. An addition from last time is that checksum SHA-1, that is an array of 20 bytes. We start with an array with all zeros. This obviously will not match the SHA that we have in the torrent file, because if you remember in the torrent file, we have the SHA of all the pieces that we want to download. And this SHA start with all 0 is obviously different from the real SHA of the piece that we want to download, so the while cycle will get in. And inside this while, we split in 16K blocks the download of this piece. We already have this buffer allocated up here for the WOO file. Where is it? Here. So is our buffer of the right size. We send out a request telling that we want to begin, and here there is a binary math basically on top of the begin to split it in the right byte in this array of U8, and this is what we should refactor in a more user-friendly way of doing this. I mean, this works, but again, is painful to read, not very painful to write, but quite painful to read. Once we get everything back here, another bad piece of code that we do is that we loop through our buffer of 16K, and we 60K or less, because it's size minus 9 byte, and size comes from the answer on the protocol. And here again, every time we do a transfer, we allocate a new vector of U8 in the heap. Again, not very optimal. But then to copy this vector inside the main vector at a specific index, we do this for loop. Again, there should be a better way, but this was the fast way that we come out with. Once all of this main loop on top of all the blocks that compose, all the 16K blocks that compose the piece are done, we compute the SHA-1 of what we downloaded through Asher, like we did maybe the last time. I don't remember, but one of the past streams we did this Asher compute of the SHA-1 of the piece. And then we copy it again with another beautiful for loop in this array that we allocated up here. At least this time is in the stack and not in the heap here. And if the SHA match, the while is not triggering again, we are done, and we are going to write the file to the output file. If the SHA is not matching, it will trigger another loop that will download again the wool 16KB. The wool piece made of 16K blocks. So this is where we are to show you that is true, that is working.
Sorry, Roberto, before we get there, quick question from Tommaso, who is asking, what is missing here? Two structs you can serialize and deserialize. I think that's probably going to be more than two structs, or maybe it's going to be an enum with all the possible messages. But yes, we should do something like that. And also,
basically, we created this request starting with I index and begin. We should create basically this array with an enumeration maybe that takes two parameters, index and begin. And given these two parameters, it gives back a vector of U8, or in this case, an array of U8. An array of U8 with the right content that then we can send out. We need this for the request itself, but we need this also for the interest message. We need it for also we can use it when we read stuff, because in the read path based on the second byte, sorry, because the first 4 bytes are the length, then there is the type. Based on the type, we can receive different type of messages from the client, from the peer on the other side. At the moment, we know that the messages will come in a specific order because we don't do anything in parallel, we don't do anything with threads. Everything is very sequential, so we know what to expect. And if we don't expect what we want, this is going to just explode and fail. Also, you have the payload type, that is this byte here. We were printing it for the bug, but then we are ignoring it because we trust that it's the right one. All of these checks are not present. In theory, we should find a way to read from this stream, and the read from this stream should give us one enumeration of some kind with a
Mhm.
content. Some enumeration are just yes, I exist, so no need to have anything in it. Some other enumeration are telling us stuff like the bit field, but then for this specific code crafter exercise, bit field is not important because all the peers have all the pieces. Interested again is an hard-coded array because it has no parameters, so we are interested in this file, yes, and that can be an enumeration and so on. So all of these arrays that we have in here could become a part of the protocol. Some are in read and some are in write. I
Mhm.
don't know now if having only one enumeration with all of them, or having two enumeration, one for the messages that can come in and one for the messages that can come out. They're different, semantically different, I mean.
Even though I think the protocol says that it can be specular, like you can technically send and receive all the messages on both sides. Now, I don't think it always makes sense, but I think you should support that kind of thing.
Oh, yeah, that is true because in the moment you are downloading from a peer, you become a peer. And in
Mhm.
theory, they can ask you to give them a piece, but maybe we can just, yeah, you can implement that basically always answering, I have nothing. So you are a leecher, you are not a peer.
Exactly.
Uh,
Let's do a super quick thank you to Mr. Alzi. So we got a raid. And for the people joining us, what we are doing CodeCrafter exercises and we are building our own BitTorrent client almost from scratch. Like we are, I guess, following the tutorial. So it's a bit guided. But yeah, we'll try to refactor it and make it nicer as we go.
so back to us, we were saying, yes, all of these arrays of U8 can become a type and an enumeration. Um, we could do that or we could go on. To close what we are doing here, like I said, we write a file, and now if I run from the console the CodeCrafter test,
Mhm.
it should do something. Compiling.
Also, in this channel,
Yes,
if
yes.
for people joining us for the first time, we do Rust stuff because we want to learn Rust. So guess which language we are choosing for our BitTorrent client.
TypeScript, right? Okay, no. TypeScript aside, test for stage ND2, you can see that we are in the stage ND2 up here. So downloading of a piece, we are able running test passed. So our code was called and we were able in the end to download these bits of the final file. If you're curious to see what's inside, because code developers are curious animals, and I remember how to run this, yay, I can download piece number 2 of this sample torrent that is locally. So if I run this, I will have in this output temp. Let's see if we can open this. And opening this, we have the content of what we downloaded from torrent. We downloaded the piece number 2, so it's the third one. So it starts in the middle of a sentence. But as you see, is some markdown of some article, maybe from Wikipedia. I'm not sure where it
I
came
guess if you
from.
download the first piece, we'll get to see the title.
Oh, okay. So yes, this is the last one. Obviously, I downloaded the last one. Let me download at this point the one number 0. And in theory, this VS Code should. What is an acre? Yeah, yeah. VS Code updated. So yes, this is what is inside that file that we're trying to download. I downloaded the chunk, the piece number 0. I downloaded number 2. Now let's go on, Luciano. What do you think in the end?
Yeah, let's submit and let's see what is the next
Okay, let's
exercise.
submit.
I think at some point we will reach a pain threshold where keep hacking our solution is not going to be feasible. So that's maybe when we should start to refactor.
My pain support. My suffering level is quite high. I mean,
Okay, good for you.
working with legacy code bases made me not feel a lot of pain. So I don't know, made me a worse developer, maybe.
Or maybe not.
So yeah, submitted. Mark this stage as completed. Yay! Next stage. Cool. In this stage, you will download the entire file and save it to the disk. You can start with using a single peer to download all the pieces. You will need to download all the pieces, verify their integrity using the piece hashes. We're already doing this, and combine them to assemble the file. Test. Here is how your test will be executed. So we need a new command called download. We have
Hmm.
an output file, and we have this torrent file that we have to download. The tester will validate the file that the file was downloaded correctly. Optional. To improve download speed, you can download multiple peers at once. Oh yeah, yeah, we can do multiple stuff to improve speed. I think those are all a factor that can be a whole stream on its own.
Yes.
Your worker connection with a peer could pick a piece of the working queue, attempt to download, check integrity, and write the downloaded piece into a buffer. Any failure, network issue, hashes not matching, peer not having the piece, etc., would put the piece back in the working queue and try again. Oh, this is interesting. Maybe there is some in-memory queue for Rust. I mean,
Hmm.
for other languages, there are stuff like 0MQ. Well, 0MQ is probably overkill. But well, there are other um, queuing system. I think we can start just downloading in sequence 0, 1, 2, done, and writing the file to
Yes.
disk all together at the very end. So not even writing the file and seeking on it. If you know torrent clients normally know the size of the file because it's in the metadata. They allocate the full file on disk, maybe we filling with zeros or not filling it, just allocating the size. And then when you write on files, you can seek in the file and write in the specific place.
Hmm.
Eh, I don't think we need to be that sophisticated because of the size of this file. Obviously, if you download that 130 gigabyte file, yeah, it can't fit in memory. But for the purpose of this experiment, what do you think? We stay in memory, Luciano, right?
Probably it's gonna be small, so it should work. But yeah, the funny story is that I remember when I started to use torrent, I didn't have like a massive hard drive, and you would run out of space as soon as you added the torrent file into your client. Just
Yeah.
because, yes, the client was trying to pre-allocate all of that disk space, and so that they could use like a seek operation to write all the different pieces. So I don't know if that ever happened to anybody else, but I remember it was a pretty common experience. And then you realize, oh, I just added a torrent of like 20 gigabytes or something, and I don't even have that disk size.
So yeah, we are not going to do that technique, even if it is the right technique when you do this kind of applications, but we keep it simple. So we need a new command. We have a command enumeration at the very beginning of this file. Also, we have a monolithic file. One day, maybe we need to make more than one file. Download. What was download the command? Let me check again. Yeah, download. This one again is very similar to the download piece, except that it doesn't have the index. So I will copy and paste and remove the index.
Hmm.
Our dash O is this short long of output string, and our torrent file is here. The next case, there was
By the
something
way,
about
we are
save.
using the
Yes, I know.
clap library for the CLI bit.
Yeah, here, clap. You can see that maybe two streams ago when we stopped parsing our self arg and we refactored it using this library. Every now and then we refactor. Yeah, we reach the pain point, then we refactor. Okay, so we have to add this command to our enumeration of commands that we handle. So I will again copy and paste because I'm super lazy. And I think we should copy and paste here because now Rust is telling us not all possibilities are handled. We don't handle command download. And now we will enter command download. We don't need the piece. We can add an okay, okay at the moment. Nope, don't reformat what I'm doing. Stay quiet, so I don't have to save until I don't have something. Again, let's look what we did at the beginning of the command, the download piece. We take the metadata, we take the peers. At least we have a function for the handshake that is common between the two.
Mhm.
Now, Luciano, what do you think? We should maybe put the download piece in a function
Yes, and then just call it in a loop.
and just call it in a loop, but we still need the number of, we still need up to here. No, we don't need the shake, but we need some of this because we need to know how long the loop is. Mm?
Mhm.
So
Correct. Yes.
we don't need the shake, but we need to get the metadata info from the torrent file. Oh, I deleted that too much. I was saying we need to get the meta info from the torrent file. We don't need the peers. We don't care about them. We care about how many SHAs we have in our metadata info of the torrent file. That will tell us how many pieces are there. So this is basically to get this counter. And now, yes, thank you. Thank you, whoever is there, called Deum. Let's snooze it because I don't like them interfering with us. And at this point, we have to loop 0 to the number of pieces that we have and call the function that we're going to write. Here is complaining about pattern doesn't mention.
Oh, you put download
Yeah,
piece. Just needs to be download.
I copy and pasted too much. Unused variable output. Yeah, because we still have to. Okay, so now we need a file buffer. The file buffer. Do we know the size, channel of the root file?
I think
Maybe,
it's in
right?
the info.
Okay, let's take a look because I
There
don't
is a
know
length,
exactly.
if I remember correct. There is a piece length.
Yeah, but we need the full file length.
Yeah, I remember where there is a field. Now I don't remember exactly the name.
Okay, let's go there. Just let me rename some variables. Our info, torrent info. There is the type torrent info.
Length. There you go. That's the entire file length.
Oh no,
Right?
there is the length is the size of the
Yeah,
file. No,
I think so.
this length here. Okay, so let's go down, 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 down. And here we just need to use meta data info.info.length. So this is all our file. Now this function needs to give back. How do we extract a function from here? We need to give back a buffer. Ownership wise, it's better to have a function that writes in a buffer that you pass it, or it's better that the function returns the buffer? When
You
it
could
returns,
do it both ways. I think it's easier if it returns it.
okay. No, because you are going to create the vector inside the function, then the function has to return the vector that was
Mhm.
created inside the function.
Yes.
I remember that sometimes we had some problems with this approach, but maybe not this time.
If the vector is a vector and not a reference, should be okay.
Is
I
a
think
vector,
the
yes.
problem is when you're trying to return a reference for something that you created in the function body. Because then once the function
Mm,
completes, it's
okay.
gonna try to
Yeah.
remove
Yeah, but if you return the vector itself, the ownership is going to pass to the
exactly
caller.
to the receiver. Yeah.
Yeah, to the receiver, that was the caller. Okay,
Hmm.
cool, 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 cool. So at this point, what we need to pass, what we need to extract from here. We need to keep then shake inside the function,
Hmm.
correct?
I guess we could, because that's just part of establishing a connection, right?
So
Which
the function is going to keep then shaking it. The length and the number of pieces to know if you are the last piece is needed. So I think that all the code that is here can go away, can go in the function, and the function is going to give back the buffer, the piece buffer,
hmm
and so all of this can go away, and we have let piece buffer equal to, how do we call this function? Download, please. Download.
Yes, yeah, that makes sense.
And it needs a bunch of variables because it needs, do we pass the meta info directly so it has everything, because then it has to extract the peers
Yeah,
and a
makes
bunch of
sense.
other stuff. So we pass meta info and we pass the index that we want.
Hmm.
Nothing else needed, I think. Once we have all of this downloaded, it's going to write to the file, and for this command, job done. At this point, these variables are still needed.
Are they still
Maybe we have.
needed?
Now, maybe we can move them in the function itself. Let's try to write the function
Yeah,
itself.
probably easier to move to the function and then refactor.
Yeah. So handshake is here. Here the main. So function, we call it download piece is going to take meta info of reference to a meta info. Okay, I passed the full meta info, but it's true, we can pass the reference.
Hmm.
And then the second one is the index, the piece index. That is, are you size an integer? What do we use?
Probably I use sides.
And is giving back a vector of U8.
Hmm.
Is giving back a vector, sorry, angular brackets of U8.
By the way,
Now,
probably needs to be an async function,
yeah,
right?
yeah, it also needs to be a sync. Yes, you're
Goes before fn.
almost there.
Close enough.
Close enough. And also it needs an S. So async doing this and that. We need to return a result because this way we can error out.
Yes, as well. Good point.
So yes, we are using anyhow. Again,
Because we're
of
lazy.
laziness. So yeah, because we use the question mark inside the function, we need to be able to use
Yeah, anyhow, it's like
give back a result.
whatever error is fine.
Yeah. So at the very end of this, we will give back an okay of what is the name of the buffer allocated? Okay, of this, just to make it happy with types. Now we need the peers that come from the meta info. So yes, I left.
We did have a function that was doing that, right?
Yeah, but I left it here.
Oh, okay, fair enough.
I left it here. Sorry. I think those 3 lines need to go in the function.
Hmm.
So now we have the peers. We need the SHA for this. We need all the SHAs, and we get the piece count. Then the SHA that we want is based on the index, but we need this array because we are using it in the while loop, in the while check here. Check
Hmm.
of this index equal to what we downloaded. Um, we need to know if we are the last one, is making the handshake and doing everything else. Now, is this enough? He's complaining about something. He's giving back that. Here, okay. Here, what we give back is a future because I don't await it.
Hmm.
Dot await question mark. Okay. Here I have to pass a reference to the meta info.
Perfect.
At this point, this is a vector of U8. Perfect. And then I can write a vector of U8 to the output. Cool. Now, we should try if this command still works, but we added this one. So let me just comment out this code for a moment.
Hmm.
He will complain that those two variables are not used. But then let's try to download again that first block, the what is an acre and so on, in another file, so we don't have a false positive. We have a couple of warnings because, yeah, we don't use all the variables. But if I open this file, what do I have?
You
I
do
have
have
an
stuff which
acre.
is positive.
Yeah, like before, and this guy is what it is. Okay, cool. So it still works after our refactor. Nice. Now, how do we use this refactor in the new command that we have? Okay, we don't need this. No, we need the piece count. Yes, but we don't need that one. The file buffer is going to be that one. And then we have to write the file buffer. The checks, okay, how do we take this out? This one is just this. Okay, now is epic. For every let this piece equal to download piece metadata info and index.
Hmm.
Yeah, makes sense. Now, horrible way. How do we copy this in the right place inside this buffer?
I think if you do file buffer dot, there is like copy or something.
Copy
Copy
from
from
slice.
slice. And well, does it allow you to, to specify an offset though?
Because we have to write, okay, the first one goes at 0, the second one goes at the length of the previous one.
Exactly. Otherwise, it's copy within. Let's see the signature of both. If there is a
Okay, copy within copy element from one part of the slice to okay, now this works inside the slice.
okay,
So no,
not this one. Let's see copy
copy from slice.
from slice.
This one copy the element from source to self using
But it
memcopy.
doesn't allow you to
And
offset.
allow to, yeah, to specify an offset. This is the same problem we had last time, and we went for the loop, remember?
Yes,
I will write the stupid loop. You will Google it in the meantime if
that
there's a smarter way of doing this. And I will try to run the tests locally just to see if at least it works. Then we have to refactor with something smarter. Okay?
there should be just a copy.
Just a copy. Let me
Mm-hmm. Didn't give you that, right?
copy. No, I don't see a copy. I have those two copies. Copies from Lice and copy within. I don't have a copy.
Mm. I wonder if you can take a mutable slice of the file buffer and then use copy from slice into that one.
Oh God. So you say to take this and to slice it with the square brackets into something. Then on top of this, doing a copy, what?
Copy
Let's
from
say
slice.
0, 0 to a this should have a length, right?
Just put a random number for now, just to see if it allows you to, yeah,
Copy from
from
slice.
slice,
And then I give it
a
it
reference
is
to the piece. Yeah,
that is complaining that I
you
forgot
need
to
to
await it.
await.
Now when I see future, I remember that I forgot to await. Okay.
So that might work as a way to do an offset, but I'm not
It
entirely sure that it
should
does what we want.
work. We try. Select mutable pointer. It start at 0. And this is from the pointer plus the length of our piece. That should have a size or length. What does it has? I never remember length. Okay, in theory, this is doing its job. It's copying the piece in there. Then we only need to increment our pointer.
Hmm.
We point at the end of the previous write. Oh, is this going to work? Magic. Let's see. So to call it, I need just need to move my cat away from the monitor. Okay, cat, go down. Thank you. Sorry.
By the way, your whatever you're using for the background is totally removing the cat, which is annoying.
Okay, sorry. I will. He's sleeping. Let it sleep. If he wakes up, it's a mess. So now I'm calling the download command, telling to go to the test file with our sample torrent, and the winner is
Why
now.
we are not using the variables? Was that the
Sorry,
old code?
which variable? Sorry.
The warning you see is still the old run, is it?
Yeah, it's the old run. The new
Okay.
run wrote nothing. We don't write anything.
Hmm.
So if we open this file, what do we have? We have what is an acre? Correct. The file is bigger than before. It's not telling me how big it is, but let's take just a optical look. Yeah, the file is bigger than before, and I think we have all of it. Now we can run the CodeCrafters, sorry, tests. It's going to run the test locally. It's not going to
Hmm.
submit to the remote server. I think in reality it's connecting to the remote servers, but it's not, yes, marking your test as done. Because it's taking some time. Now, download the full file is doing something. Stage JW8, JV8, something like that.
Ooh,
Execution
failed.
timeout failed. Okay, execution timed out.
So does it
Means
mean that
that
they want us to optimize and do things in
they,
parallel?
God, they want us to optimize already. Oh no. How big is that GIF to not fit in 9 seconds? Come on. Let me try again. I'm just curious. If it's
Yeah,
it's again.
if you time your
No, no, it's
initial execution, how long does it take? We can check after this run.
no, this time it passed. Okay. Eh, this time it passed. Could be network related
Mm,
because these tests are running over the network. Or could be that we are borderline with the performances and
yeah, probably.
sometimes it passes, sometimes it doesn't. But as you see here, this time it worked. This time we were able to download the full GIF. Congratulations. Because it's a different file from the previous run. You see,
Interesting. Okay.
is a different file from the previous run. So maybe with some sizes it works, with some other sizes it
Is it
does.
keeping that file there or is it deleted now? Just
No, it's
curious.
a remote. This is a remote file, and they don't have their torrent file. This one is on their server.
Oh, okay,
So I
because you
don't.
did
Yeah, I didn't
mm,
have access to these files, so I had no idea of anything in there. But anyway, code itself worked. So what we did was just refactoring the last one without refactoring it properly, but just extracting it to a function and calling the function in a loop n times. Now, Luciano, those are awaitable functions. In
yes.
theory, we could spawn all of them and then
Mhm.
gather all of them and write it to the disk, right?
Yes, you could.
Okay, nice. Ow.
So you can use the spawn function to
I
hmm,
never did this in Rust, so bear with me. Luciano will have to explain me everything about this.
yes. I'm just
And
wondering
also,
because if
our write to file will be quite funny. But yeah, you know what we need to do? First, we need to gather the file. We need buffers. That is going to be a vector
of
of
some
vectors
bytes,
of U8, and every vector of U8 will be
an option.
a, something that comes from our um, download piece function. And we have to call this populate this vector in parallel or in
Mhm.
parallel because I don't know, it use threads or it just do a main loop and it's just
Uses both, so uses like a work
mm,
stealing approach where it's kind of an event loop, but that can run on multiple threads. So you might have a task that starts in one thread, then arrives on a wait point, so it gets paused, but then it's picked up in another thread because there is another thread free later on. So
okay.
pretty powerful and efficient, but also a bit annoying because all the async code you write needs to be thread safe. So it kind of comes with extra requirements for you.
Mhm. Now let's park this code for a while.
That code is probably mostly good. I think we just need to do a spawn inside the for loop.
Yeah.
And then the other complexity is that because we don't know when something completes, I believe.
But can we just wait for all of them and write all of them to the disk at the end?
Mm, let me think. We could, yeah. Let's do it like that first.
So I wanted basically to push. Okay, so the type will not be vector or vector of U8 will be something something.
Yeah, Thomas is suggesting to use join all, which is, I suppose, similar to promise all in
Yeah.
JavaScript.
And to join all in Python.
Hmm.
Okay, but like I said, I never did this. What do we have to pass to spawn? The function like I'm going to pass
Like
here,
a closure, yeah.
like this? No,
But
it's
you
a
need to
standard.
make it a closure, so you need to use the pipe
Ah, okay,
syntax
okay,
and
okay,
the
okay.
arrow.
Now he's complaining that we are not a thread safe. What is the syntax again? Sorry, Luciano. Like this,
Give
right?
me a sec. Yes, yeah,
Is
that
okay.
should be it.
I was putting an arrow because I'm stupid.
But
These
spawn, is it from Tokyo Spawn or did it do something
oh,
else?
is a standard spawn. I have to use the Tokyo spawn,
Yes.
but now
Okay.
it's not happy because trait future is not implemented by the closure, so I don't need the closure. Okay.
Oh, okay. Interesting.
The normal spawn wants the closure. Tokyo spawn doesn't
Hmm.
want the closure.
Makes
This is
sense.
already a few unawaitable, and is a result of vector of U8. Now I'm trying to push in the wrong.
Yeah, what does Tokyo Spawn return in this case? Because you
Uh,
probably need to await that, or probably what you want to do is put this the result of Tokyo Spawn into some kind of array,
pool.
and then in that
Yeah,
array we do join all.
I called it pool, but okay, maybe we can let it infer the type on its own. So the type is a vector of
Exactly.
join handle result whatever. Cool. Here is complaining. Meta info doesn't live long enough.
Why doesn't it live long enough?
Create it here, and we just
Right,
pass a
because
reference.
the task that you are creating in that for loop might be finishing after the function spawning the
Yeah,
task.
because we are still not awaiting it. Now let's await it. Where is the join all? Or what is the join all?
Tokyo. No, it's future join all.
Is Tokyo join? Waits on multiple concurrent branches, returning when all branches are completed. I think is what we want.
Okay.
And
Let's see if there is an example.
you have just to pass them as parameters to the oh god, because we have them inside the pool vector. How do you, because we don't have a finite number of them, we have a
Okay, there is a
not
suggestion
known
here.
number.
Sorry, just a sec. I'll give you this link because it's probably easier to follow from this link. Thank you, Tommaso, for the suggestion. So basically, if I understand correctly, the suggestion, we don't even need to use spawn. We just need to put all the futures in an array and then call this join on.
Okay, fine, even easier. So let's copy and paste like animals. So our vector becomes simpler. We are doing our vector, then we do a join all await, and it will give us back an array with all the pieces. Perfect.
Yeah,
Nice,
seems
nice,
simple
nice,
enough.
nice. Yeah, way simpler than this. So here we are just pushing the future itself without Tokyo spawn
Hmm.
inside our pool. Then we do this join all of our pool dot await, and we do let our buffers equal to this. At this point,
Perfect.
our buffers will be a
Doesn't know.
it will be a
Interesting.
okay. In theory, is a vector of the results, so it's a vector of U8 in theory.
Or a vector of result vector, yeah.
Oh God, you're right. The result of vector, but well, do you know what? VBG exclamation mark of buffers.
I am surprised that now it's not complaining anymore about meta info.
Maybe it's this way is smarter. So if we run this again locally, it's not going to write the right file because user undeclared the creator module. I forgot to import it. I need to import it. It's not in the core.
Oh, we never installed it. Yes, yeah, it's an external module.
Perfect. So let's go and cargo add. What is the name of the cargo?
It's what is it? Futures.
I can try futures, but I don't want to install the wrong stuff. Then
Yeah, it's futures.
futures. I mean, I hope we don't need any strange feature.
I don't think so. Fingers crossed. There is a futures executor there, which no idea what it
Look,
does.
if we don't have the right stuff, it will complain. But now, back to us. Futures join all. Now it's giving me help. So, and here join all is complaining. Operator can only be
Okay,
applied.
doesn't need the question mark. Because I think it's giving you, if you go to buffer, it's giving you a vec of results. So if anything fails, you will get it in the specific
Okay, now we have a
place.
vector of result of U8 or an error. Cool. So we have all our bit and pieces.
Hmm.
What we do now is that, in theory, if there is even one error, we should loop and try again. Or we should
Hmm.
retry just the one that failed, but this is very advanced. So what I will do is just looping through the buffers. They could be question, join all. we added the first one that is the with index 0, the second one with index 1, the third one with index 2. In this buffer, the order is preserved.
I think so. Yeah. If
Okay,
you
so you
highlight
can loop
join all,
in
I think
order.
it will tell you. The return future will drive execution for all its undefined underlying futures, collecting the result into destination in the same
Yeah,
order
in the
as they
same
were
order.
provided.
Perfect. So I don't need to care about ordering. Now, at this point, instead of looping on number of pieces, I just loop in. Um, how can we do this nicely? I mean, we can do buffers length, but there should be a better way of doing this.
I don't know why Tommaso
Because
founds ironic that we have a vector of results of vectors. I mean, yes, it's not nice to work with, but what is the option?
why why is that good? I mean, we can unwrap the result. Yes, why not? But
I think also there is some shortcut that when you have a vector of results allows you to say, give me a result of vectors, and it's gonna be the full vector if everything is a result, is an okay, sorry, result, or if one of them is an error, it will be the first error found. Oh, okay. It was saying the last cool is ironic.
oh, is cannot move out of index as ref or as moot.
Okay, let me see if I can find that helper. I saw it once, I'm quite sure.
Thinking about here as ref. Okay. So now what I'm doing, I'm looping through the buffers that we get, and like before, I'm writing them to the slice of file buffer. We could use this everywhere else. We did the horrible loop, but that's time. And
Okay, so
then
you want to
we
know
have
how to do the magic?
let me test if this works. If this works, we can try the magic again. Okay.
Okay.
Now let's do a code crafter test. This will run remotely and see if we get a gift that is big enough to make. I mean, in theory, this time it should be. Why? Ah, we added a dependency. It's building. Why it's taking so long? Because we have to compile again.
Yeah, meanwhile, Tommaso spoiled the magic, but thank you for that. So basically, if you do a into iter and collect, Rust is able to collect into a result of vector. So if you collect into kind of the opposite nesting, Rust is able to basically, yeah, the logic I think is that it's going to iterate over, and if everything is a result okay, you collect all the vectors, no problem.
Oh,
If one of them
okay.
fails, you get a result error.
Okay. When this is done, we are going to do that. Is better than what I
Hmm.
wrote.
I think, yeah, it's much nicer to work with because at that point it makes sense if the logic is if just one download fails, then you want to fail everything. So at that point, you
Yeah.
have one result that represents everything failed.
Yes. That is the logic. I mean, or you retry, or you just give out an error to the console in this case.
Hmm.
But sorry, it's building remotely because we added a dependency, so it's taking a while. This time it's not my machine fault.
Good excuse.
Yeah, all excuses, sure. I hope it's building remotely. What is doing? A coffee?
Yeah, we need a coffee time.
A slide for coffee? No.
Nope, we don't have a. We need like a please hold type of music.
Do you want me to kill and try to restart it? Because it's taking a lot.
Or you can open another terminal. Too late.
Nah, nah.
Now we are gonna create a denial of service of their own servers.
Can you go and check if CodeCrafters is up and running? Oh, we broke it.
Seems to still be running.
Yeah, there is a page with the statuses of the testers somewhere. But well, anyway, let's test it locally with this file that we were having before, just to see if it
Oh wow.
works.
Today the hosted BitTorrent tracker and peers is down 2 hours and 30 minutes ago. It wasn't our fault 2 hours ago.
Unexpected end of file. We got an error unwrapping in line 424. Unexpected end of file. Okay, let's do what we were suggested to do. So we were saying now buffer is this vector of results. To do the other way around, I have to declare it as a result of a vector of something, comma something, and close it, and result as lowercase e.
Mm-hmm.
Okay, and here I have to just do
Into either and collect.
iter and collect. Okay,
Yep.
step. My cat is in front of the. So now let's be rude and unwrap it. I mean, I know that we should test. Now let me unwrap it. I don't have to unwrap it here anymore. Collect is complete. Ah, well, collect can't do that.
Mm-hmm.
Let buffers equal buffers dot unwrap. Do a little bit of shadowing. Then here is complaining that cannot move out of index. Move occurs which doesn't implement copy. What a reference? Reference is fine for me.
Okay.
Okay, let's try again. Sorry, cat always in front of the monitor. No panic. Unwrapping at line 421. So it was not able to unwrap. We have an error here.
So one of the pieces returned an error.
Yeah. The debug buffers just to see what is in there. Kind and unexpected end of file.
Okay.
This is our code that is giving errors, the one with the tasks. Because the previous version that I didn't commit it because I forgot
Mm-hmm.
was working. The one with the loop without the pool, without our pool. So is our pool the problem?
So if you set up the environment variable rust underscore backtrace to 1, I think we might see a little bit more information, maybe.
I'm fighting with the cat.
Oh, we can see the tail.
Yeah, he wants to sit on my keyboard, but
Yeah, he knows the solution.
yeah, now he wants to use the mouse. It's complicated to work with this guy here. Taglio la coda.
Okay, that's not very helpful.
No, I panicked because he was not able to unwrap. Thank you, but I don't know why he's giving this unexpected end of file.
Okay, can we debug? You were debugging the entire buffer, right? But what does it show?
The entire buffer is just one
Oh,
element.
no, 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 wait, wait, wait. Yes, because you are debugging after we did that
Oh,
inversion.
okay,
So we'll need
okay,
to,
okay,
let's do it in two steps.
okay.
Fubers.
Don't make me laugh, please. Okay, so let's do this, let's do that, debug here, debug there, into item collect. Okay, so
Perfect.
one, two.
Now I'm curious to see. Oh, we have a few there that are failing. Yeah, you have
Wow.
16 kilobytes of numbers there.
Oh, more because the piece is more than the 16K is ah, the first
But
one worked and the other one didn't. Why?
the last two failed, right?
Last two failed. Oh, do you know what? Are we opening different connections? Is how
Mm,
we handle the protocol. Is how we handle the protocol because we are giving all the commands to the peer in the same moment. So it can be that we get back the answers in the wrong orders, and so the single functions are interfering each other at protocol level.
not sure I'm following that.
I want piece number one. I want piece number two. They answer to you, but instead of answering, I mean, if there are three TCP connections, this should not happen. But if for some reason Tokyo is reusing the same TCP connection,
But we create the connection at the download piece level, right?
in
Or not?
theory, yes. Yeah, yeah, we
So
created
they
the
should
connection
be
in this and shake.
independent connections.
Uh, Here, I don't know how Tokyo works. I mean, if in Tokyo you connect 7 times to the same port and of the same machine, do you have 7 different streams that are isolated, or you have
I hope
streams
so.
that are together? Oh, then I don't know what the fuck he wants. Because it's always only, it's always like this. I mean, if you run it again, the last two are always failing. Now, okay, the last one, OS, connection reset by peer. Ah, it can be that the peer doesn't want us to connect more than once.
All right, that makes sense.
They don't want us to connect more than once, so the free download function should share the TCP connection. But to share the TCP connection, we have to implement the proper protocol, because at that point the answer can come in a different order than what we expect, and we need to take that in account.
Hmm.
So my proposal is, let's go back to the working code, submit this, and next time we can refactor this. What do you think?
Yes. What was the working code? The one without spawn, because we were.
The one before spawn. So I need to
Okay.
control Z a lot, or I need to rewrite it. Let's see how far back control Z goes.
Yes. The other thing I was thinking is that we will have multiple peers that have the file, so you should probably consider using multiple connection, but one per peer. So in that sense, maybe a queue makes sense where you push all the
The suggestion was to use a queue, yeah.
yeah, you push all the operations, which every operation is like download piece one, download piece two, download piece three, and then whoever is free in a connection pool gets the next piece to download. So you have as many workers as you have peers.
Can leave futures here, but let's leave it there for this time. Okay, was this their working solution?
Yeah.
CoderCat was failing before.
So Tommaso is suggesting we should use Kafka. I don't.
CoderCat was failing. We run it again.
Do you want to use Kafka, Roberto? I know you are a big fan.
Yeah, I like it. Overkill stuff a lot.
We will be turned into cockroaches if we do that.
Okay, and now it passed. So let me try to submit this so we have a commit and we can go on from this next time. What do you think?
Mm-hmm.
If it's not giving me the cat, it's giving me the cat if it's going to fail. Compile again.
Okay.
Congratulations. I should pass this. This one is smaller. Cool. Passed. Okay, we passed, but we know that we have a problem with performances, and somehow we interfered with the threaded approach because the peers don't want us to connect with more than one connection, maybe. Now I have to find where is CodeCrafters here. Okay, test passed. Mark stage as completed. Cool.
Nice.
Done.
That was the last one. So we're technically
This was the last one before getting into magnet links.
was
We have
just like an
covered
extension.
one,
Yeah.
yeah, 1, 2, 3, 4, 5, 6, 7, 8 points. If we want to also implement magnets, but I think we have material for the next stream because we have to do all the refactor, guys.
Mm-hmm.
All of this in something nice.
Yes, will be curious to know if anybody knows any good like in memory queue, but that's a question for
I
the
u-
next one.
I used 0MQ. I don't know if it exists for Rust. I mean, it exists for a lot of languages.
It's
It's
written in C,
compiled.
yeah, and there are
Yeah,
bindings.
it's written in C. In theory, I mean, search
There
for
is a crate.
0MQ in Rust.
Oh, there is a native implementation. Somebody entirely re-implemented it.
Yeah, there is a cargo add ZMQ that is the official one. There is the native one that is a 0MQ, not ZMQ. Yeah, so cool. We can try to use this. I mean, it's overkill, but it's going to
Does
work.
it also implement a queuing mechanism, or is it just for networking patterns?
I was remembering that it was implementing the queuing, is implementing PubSub, is implementing a lot of stuff. But you can use it locally in a single application, from what I remember.
Mm-hmm.
Anyway, we can do a little bit of research before next stream and find a library to use for the queue and use a single TCP connection to the peer or to multiple peers. But if we land on the same peer with two different tasks, we needed to share the same TCP connection because the peer is not allowing us to open a second one. So
Mm.
there we need to refactor a little bit our code to make this possible.
Okay, yeah, we'll definitely need to do a few refactor. Meanwhile, we are getting suggestions to use channels and crossbeam. So we should look into that.
Yeah, we have a lot of stuff to look into.
All right, so let's wrap it up. So,
Wrap.
yeah, what I have to say. I always forgot this bit. Yes, thank you for following on. And we are going to be publishing, as always, all our code on GitHub. If you're watching on YouTube, the link should be in the show notes. And yeah, so if you're watching on Twitch, go and check out our YouTube channels with all of the recordings and the links in the descriptions. We generally stream every Monday, 6 p.m. GMT. We haven't been super consistent lately for various reasons, and also Christmas is approaching. So our schedule is going to be easily disrupted, but hopefully we should be able to stream next Monday. So hopefully we'll see you then. But Otherwise, keep following along on our social channels where you'll be notified when we go live. So thank you very much and see you in the next one.
Bye.